Video number 4, take 1. A question came up a couple days ago about measuring what it would take to make the two halves of this multi-layer buoyancy device float. And because of the way I have this one set up and some of the things I can do with it, there were a few approaches I could take there to try to provide those numbers. And the reason for this video is to just demonstrate what can be done wrong, actually. And it's easy to visualize now that I have this little, we're calling it a metering board, where you can really see the levels of water inside the various columns inside this device. I'm starting out here just to show what should probably be considered a typical setup. And the reason I say that is because, as it's called, a buoyancy device, there really needs to be a higher water level outside of each of the floating sections than inside. And that's what we're seeing right here. The water level is higher, water level is lower. Higher, lower, higher, lower. And I've been tempted to put on this background chart just a little diagram of what is actually inside the cylinder. But if you could picture, there's a separating wall here, and a separating wall here, and a separating wall here. Each of these is basically a stacked inverted cup, and the buoyancy provided by this differential of water levels is pushing upwards on this top plate. So to start, I'm going to release what's holding these water levels as they are and demonstrate what happens if you try to do things backwards. Now, as you can see, all the water levels are the same across all three of the layers that are inside this, and normally I would start injecting air into the center, which causes the pressure of the air going in to push those levels in the right direction. The higher pressure needs to be towards the center, and from there I can work outward and I can keep injecting air and keep those levels increasing. But what you'll also see happening is as this level separation gets greater, this one will get smaller. Pressure is building in here and it's compressing some of the air. And if I want to rebalance, I can go back and I can add some air to replace that compressed pocket that developed because the pressure grew. And if I really wanted to hold all three the same, which I've tried a few times, it gets incredibly challenging. I'm going to go back to 0. If I start from the outside first, so we're back to where we started. Now what happens if I start putting air in, working from the outside in? And this level goes the right direction. Haven't seen a whole lot happen in the other two yet because we are building a little bit of lift. I'm mostly locked down, but not completely. There we go. Now because the pressure is building from the outside in, it's actually pushing these two the wrong direction. There's a higher air pressure here than there is here or here, and that's what's causing these two levels to do what they're doing. And what this is even causing to happen is now there's less buoyancy here and here than there was when we started. Now if I try putting a little air in the middle, that one section will start to balance out, as you can see here. This one will grow, Okay, the middle's going the right direction now. The outer one, where I started, is still the right direction. And the center is starting to react a little bit. And I can balance it out more by going to the center. And we're just getting a little overflow because I maxed out on the outside. But the whole point of this was just to show that air pressure inside this device is very critical, and it has to be balanced, and it has to be placed in the right order and in the right places. The whole goal here, if I'm understanding this process correctly, is really to develop what could be called a symbiotic relationship between pressure and volume. And if the two aren't balanced and don't work together the way they're intended to, then the device isn't going to work. More to come. Bye.